Hi, I'm Veit, and today I want to talk about implementing an IDE in GT, the Glamorous Toolkit. But before we go through the hows and whats and the ins and outs of this talk, I have to answer the question why. And I just think IDEs done right are downright delightful. And I think in this audience, most people would agree. Small talkers like their IDEs. But sadly, I think for the wider tech community, that's not always true, because most of us are stuck with glorified text editors. We have IDEs, they're called IDEs, but really they're a big pain for text, and then not much else. Maybe a text-based debugger, but that also doesn't get us very far. That's because we don't spend the time and the resources, and because for some environments it's just downright hard to make something delightful. And so we resort to our actual text editors because they integrate better with the system. Some of us might use a text editor that's based in a terminal like Vim, or an operating system that also happens to have a text editor like Emacs, or maybe even resort to Notepad, right? And so we end up reading text and writing text and thinking in text. But of course, most of you know that code isn't actually text. It happens to be encoded in text, but that's kind of, it's incidental almost. Code doesn't have to be text. Code is not prose. And so I think we can do better. And I think you think that too. And so this is my little idea for how something could be built that could be better. This is a module coder for Carp. It is very tall and skinny in this slide, but it doesn't have to be. In it, we have the module example, which uses the test module in test.carp. If you can't read any Carp or you don't know Carp, which is all of you probably, don't worry about it. We're not even looking at code yet. We have some documentation. It doesn't tell us much. It says example module documentation, but we have documentation. And if we click on the methods tab, then we actually see what kind of methods are defined in the module. It's two of them. One is called X, and it's dynamic, which means that it's available at macro expansion time. Yes. Carp has macros. We're going to talk about that later. And the other one has a scary function type that says it takes an integer and a type A, that's a type variable, and it returns that same type A. If that doesn't tell you anything because you're used to dynamic typing, don't worry about it. We can expand this just for fun. And for the first time, we realize we're dealing with a Lisp. We haven't looked at any syntax yet, but we already understand the module. I think that's kind of cool. But now we look at syntax and we see that we're defining a function that takes two arguments, A and B, adds those, and before it adds them, it will also convert A from an integer. From int is what is called an interface in Carp. It just means that it's a function with multiple implementations depending on the type. So you can convert many things to from an integer to its representation. Now that's kind of neat, but if we put this in a pager in GT, we can actually use the buttons. I mean, we can use the buttons otherwise too, but it's going to spawn somewhere else. In the pager, if I'm going to click on this little thing that's going to tell me generate source, I now get the text-based source. And if you can't read that because it's too small, don't worry about it. You don't have to read it. But basically, it's going to generate, the documentation annotation. It's going to say, define a module example that uses test. And then inside, on line 4, in this tiny module, we actually start looking at the code that we care about, which is the functions. And because I didn't want to deal with that sort of stuff, I built a little module coder. But that's only half of what we have. This is a Lepiter snippet, also a regular coder, but it's also an integration in Lepiter. So you can just, if you load GT for Carp, which is this integration, and it's available as a regular old baseline, if you load that, then you can have custom snippets for Carp. And in this case, we're defining a function main. We're printing something with the I/O module, and then we're doing something else. It doesn't really matter. But more importantly, we have the buttons down here. And again, I'm going to put this in a pager, and then we can play around with the buttons. But maybe we should spend a second trying to think about what this will result in. So it's a case expression, and it's going to add 0 and 1. And if it's 1, it's going to return OK to println. And if it's 2, which it shouldn't be, it's not OK at all, which is appropriate. And if it's something else, we don't even know what's happening anymore. If you don't understand the ampersand and @ sigils, don't worry about them. We're going to gloss over them now, and we're going to mostly gloss over them later. Now, I put this in a pager again, and I can use the buttons. So the first one will evaluate. The second one will inspect. Inspection gives us nothing because it's just a function definition, and a function definition doesn't do anything on its own. But because it's the main function, we can build an executable with it. A main function is in the old tradition of C and C-like languages, so we can build a main function and build and run, and then if we do that, then we're going to see the console output, OK. We're going to see the exit code of the executable, which is 0. And we can also look at raw output and so on, but that's not so interesting. What's more interesting are the other integrations, like expanding the macros in here. And then we see that the ampersand actually gets expanded to ref. If you can't read any of that, again, don't worry. It's all Lisp. It's all a weird language that fell out of time. The at gets expanded to copy, and the case is actually a macro that desugars to let and a nested if statement. All right, but what if something goes wrong? So in this case, we're saying if something is true, and then we say true, but we're missing an else branch. Case statements have to have an else branch. So if I try to evaluate that, I get a debugger. But the debugger is on Carp code. So here it says macro error, case has even number of branches, add an else branch. That's helpful enough, but if we don't understand it, we can still step through the execution of the Carp code if we want to. We have the stack trace, we can look at things, and that's kind of helpful. It's especially helpful because I write a lot of macros, and macros are annoying to debug. Especially if all you have is what we have on the right here, the stack trace. Now, with the debugger, it's a little bit nicer. So let's take a step back before we go through how to implement something like that and talk about what Carp is. And I'm going to throw some lingo at you. It's a statically compiled Lisp-E programming language. It's not a Lisp. It just looks like one. It has macros. We've already seen those. It's the classic common Lisp def macro kind of thing. It has type inference in the vein of like Haskell or OCaml. For those type system aficionados amongst you, that's Hindley-Milner type system or Hindley-Milner Damas. It's basically just building a bunch of unifications, and it's quite nice. You don't need to worry about types most of the time, basically, but they're still there. It is more closely related to OCaml in this vein than Haskell because it doesn't have a lot of the fancy things that Haskell has. It does have some in product types, which are structs and option types where you have multiple constructors for a type. If none of this means anything to you, don't worry. I just want to make sure that we're all that we have the background that we need. And we have borrow checking, as in Rust. That is a somewhat simple method of not having to garbage collect, but also don't have to manage memory manually. So we get to kind of infer lifetimes of things, and destructors get inserted into the code ahead of time statically. It's quite nice. It disallows a whole class of programs, but it also disallows a whole class of bugs, and that's a nice trade-off usually. But I mostly saw it as the perfect challenge because it's so far away from Smalltalk. I mean, it has types, it has macros, it has all of these things. It helps that I, sorry? Yeah. I'm sorry, of course, it has static types. And of course it helps that I'm contributing to the language, but mostly I just wanted to see whether I could make it work. Because if I can make that work with all of those weird features, I feel like I can make anything work, right? After that, something like Python or JavaScript feels like a breeze. I also wrote a little booklet about how to do this. It's part of the GT for Carp repository. So if you download that, you get a little Lepiter booklet that walks you through the process of building everything about this. It's a little terse just because there's a lot of moving parts and I didn't want to, hand you everything. You still have to read a little bit of documentation and so on, but it gives you all the pointers. As a brief aside, this booklet has in the appendix a page called Presentation at ESUG. And we're actually, if I minimize this, inside that page. So this is the booklet running inside the presentation, running inside the booklet. I think that's pretty cool. All right. So what do we need to make this work? This is the technical part of the talk. We need a SMAC parser. We need a syntax highlighter. We need a language link integration. Yesterday, when we talked about the remote runner, we heard about FaroLink, which is the Faro version of Language Link. Language Link is the underlying technology that powers these servers. We need a custom snippet type, and with it a custom coder, but I'm going to get to that. We need a handful of weekends, or maybe longer, or maybe shorter, depending on how fast you get started. And then views to taste. I personally added the module coder. That's not applicable to all languages, right? Not all languages have modules. Not all languages' modules look like modules in Carp. So you will have to think about what you want your views to look like. Let's go through the components. So first of all, we have a parser. And if we look at this parser, we don't need the sidebar, I don't think. If we look at this parser, it's a standard SMAC parser. It has a bunch of rules. It's actually quite easy to parse Lisp languages, but it's still kind of involved, and that's mostly because I wanted to have a real abstract syntax tree and not a parse tree. SMAC can provide you with both. If you don't tell SMAC what to parse things into, it will generate a parse tree, and then you have a tree with a bunch of text in the nodes. But I already told you that I don't think text is a very good medium, so I would suggest, if you're building your IDE, build a real AST. And you do that by saying in the source of the parser what you would like your expressions to look like, with the prefix and suffix and root. And inside all of the parses, you say what to parse into. This little thing here just means that you should parse this into a node called map. The rule is called map, and we parse into map. And then if we try this out, we can test this, and I'm just going to use a map. I'm going to write some nonsensical code, but just to show you maybe what we're doing here. So you get a start node, which is a list of expressions. And then inside the expressions, you get the list node, which is this thing. So if I click on that, I see that's what that parse is. And then inside that, I have expressions again. A variable node, plus. A number node, 1. another variable node, a, and then the map node, right? So that's kind of how we parse things, and it kind of helps us to have a little bit of structure before we start with the more interesting bits. Now, once we've done that, we want to highlight our AST. And all you have to do in GT to make that work is you have to add one method to the class GT SMAC parser styler. In this case, it's called Carp styler. It takes a parser class. We don't care about what that means. It will have in the annotation the name of the parser that it works with, and then it has a bunch of rules. And if I expand this again, you can see the rules. It's just really just, you know, a keyword should be bold and should be purple and that kind of stuff. I also went the extra mile, and if you see here in the Smalltalk code, kind of the parentheses have colors, and they're color-coded according to their depth. And if you click on, you know, the parentheses, you see where they start and where they end. I wanted to have that for Carp too, so I added that in the Carp styler utilities. If you want something like that for your language, you can just take that verbatim and it will work for your language as well. Yeah.
The styler rules, they are part of SMAC, or this is a GT extension?
They're part of, if I remember correctly, I'm not the expert here. Sorry? Oh, yes, of course. Whether the styler is part of SMAC or a GT extension. If I remember correctly, they're part of GT for SMAC, so the GT extension on top of SMAC. All right. Then we need a language link. And I'm just going to talk about the client here because the client is inside GT. The server can be anything that understands the protocol. I personally didn't want to understand the protocol, but I wanted a server, so I just took the Python server and stuck a Carp process in there, and it kind of worked. So I still don't understand how the protocol works, but I also don't need to. There is an implementation for it. If you do want to understand it, you're a better person than I am. Now, on the client side, we need to tell the server and client what ports to run on because they work in sockets. And then we need to say which message broker strategy. In this case, HTTP. I think we also have message pack if you're interested in that. And then you kind of give it a process, you give it a platform, a command factory, you give it a serializer and the parser. That's a lot of stuff. But the important bits maybe are the Python process, the server process, which in this case is the Python process. It just gives you, you know, this is where the executable is and so on. The platform, which basically instantiates a new platform. Every time you start an application, it will make a fresh directory and run Carp inside that fresh directory and so on. In the case of Python, it actually will create a virtual environment for your system every time. Carp doesn't have that notion, so we don't do that, but you could if your language wants that. And then the command factory is not super important. I don't think that I did anything there, but the command is also interesting because it takes a stream of instructions and it makes code that the server understands from it. In this case, it just joins all the instructions with space and replaces all carriage returns by line feeds. Simple enough, but you might want or need something else, like, I don't know, add semicolons or add whatever you want, right? So that's kind of it. That's all you need to do on the language link side. It's a lot, but it's doable. And then we just have the snippet. The snippet is easy. It itself doesn't have a lot. What's not easy is what the snippet contains, which is the coder. The coder is the actual thing that has all the buttons and does all the stuff and executes things. But I suggest if you want to start with this, you start with the snippet because the snippet holds on to everything else. If you start with the coder, you might never realize that you even need a snippet. Now, you go with the coder, and it has a bunch of stuff. But the most important thing is bind and execute. Bind and execute literally will bind all variables that we need, do all this stuff, and then send whatever execution we need over to the server. So that's kind of, it's a mess, but it works. And now we can take a quick breather, because that was all the code. That was kind of a lot. You do need a lot of code to make an IDE work. But really, I don't think it was too much code. It was enough code for me to write it alone on a couple of weekends, and we built an IDE. That's pretty doable, you know. So what I want you to take away, even if you don't believe that it's all that doable, or if you don't believe that it's all that great, I think one of the takeaways is that a non-trivial amount of work goes into building an IDE. Well, duh. But also, most of it happens not inside the code, but when you think about what might be interesting to add, what might be interesting to abstract away, and that kind of things. I spent more time thinking about how to make modules work in a way that allows me to do everything I do in text, but not have all the bloat of text, you know? So I think that's where more of the work happens, but it's also more flexible than sitting down and writing code. And I want you to take away that it can be done by one person. And I think that's pretty cool. And lastly, I want you to keep sending the message that this IDE, it's not the same as this, which is a bunch of text. And you already know that. And I have to add a little low note to this before we pick up. And it's kind of my fault. No one in the Carp community cared. No one wanted that tool because no one understood why it was useful. We all have text editors. Why do we need an IDE? And maybe they didn't see what I saw, and I wasn't able to tell them what I saw in a way that was understandable, I think. But some of you might be able to. On another note also, to make it a little more positive before I leave you, is that it doesn't matter. It doesn't really matter that no one else cares about this tool because it already made my life writing Carp so much better. And I've done things that I would otherwise not have done. I've written more complex macros because I can debug them more easily, that sort of stuff. And really, then in the end, those few hours that I spent were well spent, I think. And maybe they will be well spent for you as well if you want. You can always contact me if you want to do something like this and you're interested in getting started. Otherwise, have a great day, and if you have any questions, shoot them at me. Yeah?
Maybe correct me. The first question is the language server a specific API that is for GT or the language list?
Yes, it is a specific. So the question was whether it's a specific GT-based API, and yes, it is.
Why not using the now popular?
Something like language server or something? Yeah. I asked myself the same question. I don't have an answer yet. I don't know. But maybe, Alistair, do you want to pipe up? Sorry?
Repeat the question.
Why do we not use something more popular like LSP for the server implementation instead of like a custom language ling thing?
Basically, we're trying to keep the MIT license to short networks out, and essentially we're trying to get as much of it as possible installed to because it gives us the most flexibility. And
All right.
Python tools already existed, we weren't inventing something.
All right. Okay. Anything else? All right.